Thank you, Justin, and good evening to all of you. I'm Bruce Messenger, Superintendent of Boulder Valley Schools, and we're thrilled that you're here this evening. I want to first of all recognize we have some members of our Board of Education here, so if they would just give a wave or stand. I see Tom and Shelley off this way, and we've got folks scattered around, so they're among you. So again, thank you. As you all probably know, we have a 7-member elected volunteer Board of Education, so again, one more example of their service to all of us is to be here this evening. So on behalf of the school district and our Board of Education, we want to express our appreciation for you taking time this evening. We scheduled this evening to give us an opportunity to share with the community some information. So as you came in, you picked up materials, and Marilyn's going to be our facilitator, and she's going to walk us through that, and then we're going to hear some fine presentations. We understand that this has been a complex issue, and it's gone on for a long time. And we regret both that it has gone on a long time and it's taken us this long to get to where we are, but we've made good progress, which you're going to hear this evening, and we think we are in a good place. And our primary concern, after we think about all that we do for children, it is their health and safety and of our staff that work with us every day. So this has been a high priority for us, not just my office, but throughout the district, our operational staff, our folks that work in the field, and the consultants you're going to hear from this evening. And so our intent tonight is to give you some good information. There are going to be time for you to ask questions on the note card, so please do that. We want you to leave in 90 minutes with as much information as possible. So again, thank you for being here. Safety is our first priority, and we're going to make this worth your time this evening. So I'm going to turn it over to Marilyn. Marilyn Salzman is our facilitator this evening. So Marilyn, thank you for being here.
Thank you for coming out on this snowy evening. I want to talk a little bit about the purpose of the meeting before I introduce our guest speakers. So tonight we have a panel of experts who have been working with the district, whom I'll introduce in a moment. And it's a unique opportunity. A lot has been happening in the last week, 2 weeks since spring break, and the district and the experts want to update you on what's been happening in the last few weeks. And when you came in, there's quite an extensive handout about what has happened over the last 4.5 years. So we hope that you take that home with you and have some time to read that and review it and see what's been happening up till now and then what's happening right now. Tonight is designed as an information meeting. We're privileged to have these panelists come talk to us, and we want to have as much time as possible for them to answer your questions. And I know there will be a lot of questions from the audience, and we want to take that time and honor everything you want to know. As a result, we're also filming the meeting tonight, and this will be available on the district website, as well as all the questions and answers. If there are more answers and questions that we can get to in the hour and a half that we have together tonight, we will answer those questions and make the answers available on the website. We'll also have you submit future questions if you want to communications@bvsd.com. So we want to make sure this is an open process and that all your questions are answered. We do plan to end the meeting on time at 7:30. Tomorrow is a school day. It is snowing outside, so we want to be very respectful of your time. We ask that you listen to our panelists with respect and let them tell you what they have to share, and then we'll have time for questions. Hopefully you all had the opportunity to pick up some cards as you came in so you could write down the questions. As we go through the presentation, please write down your questions as you think of them, and we'll be collecting them, and we will have a question and answer session after all the panelists have spoken. So if you have a thought, I encourage you to write it down as that thought comes to you or question comes to you. We wanted to do this format so that we could answer as many questions as possible, and we also wanted to give everybody the opportunity to ask questions. Some people have been studying this issue for a long time and have a lot of information. Some people in the audience may be brand new to the issue tonight and will have different kinds of questions. We may have some people who are using translation services tonight. Some people are very comfortable in front of a microphone. Others may feel more comfortable writing an anonymous question. And so that's why we're using this procedure. Does anybody need an index card right now? Or did everybody get them as they came in? Please raise your hand if you need some cards to write questions, and we'll come around and get you some index cards. So at this point, I would like to introduce our speakers. Looks like Dr. Pacheco is not here yet. She might have had trouble driving up this evening. Richard Shaughnessy will be speaking shortly, and he has a lot of expertise and has been working with the district, and he's doing a lot of studies, as you'll see in his bio. The bios of all the speakers are on the back of your agenda, so I'm not going to read them to you, but just know that they all have been involved with the district. They've been looking at the air quality issues and will share their findings with you. Dr. Shaughnessy is with the University of Tulsa. Brad Turk is president and building scientist with Environmental Building Sciences and has many, many years of looking at environmental issues in buildings. And Dr. Mike Van Dyke is with the Toxicology and Epidemiology at the Colorado Department of Public Health, and previously worked at National Jewish, and also has many years of experience in environmental issues. So these experts will be spending time with us tonight to share what they've learned about the district and to answer your questions. Please help me welcome Dr. Shaughnessy, who will be the first presenter tonight.
Good evening, and can you hear me okay? No? How about that? Better? I'm going to talk to you briefly, and in doing so, I've got Mr. Brad Turk here with me as well. You know, just for our information, I kind of wanted to know, it's better out of the light there so I can see you, but how many community people do we have here tonight? So parents as such. Great. And staff, teachers. Okay. And then we have board members too, as I saw earlier. Okay, wonderful. Well, we've got a good mix, and we're going to, I mean, from my perspective, we're going to do the best job we can to answer your questions. So, with that, let me make it clear, you know, trying to, I hope, avoid any confusion or further confusion if there has been any. I have made, nor has Brad Turk, made no public statement, nothing, no representation publicly other than tonight. So tonight you're going to hear what we know, what we found, and what we're doing, okay? In the past, I guess, I've read a few things that said Dr. Shaughnessy said this or that. Well, tonight, we'll go through what we know, okay? Again, I'm program director of research at the University of Tulsa. We started in 1987. My other speaker is Brad Turk, my co-worker, and when you do indoor air work through the years, I mean, you find that you need a team of experts. It's not one person. You absolutely need all different walks, and we have that to some extent. Definitely working as a group, trying to resolve the problem here. I'm sorry? Okay. The University of Tulsa, I just want to give you a quick background. Since 1987, the program was first established, and in doing so, I've worked with over 150 school districts in 24 states on IAQ management and research, affecting over 2.6 million students. So we've done a lot of work, and as you see there, much of the work has been on behalf of the EPA. We've done a lot of outreach for the EPA, and we do a lot of work in school districts around the country and internationally in Europe as well, trying to resolve problems and diagnose and look to improving conditions in schools. That's really our goal, And with that, again, background, when I think of an ideal classroom, I think of clutter-free, I think of daylighting, I think of adequate ventilation, I think of clean and cleanable, I think of track-off mats. I mean, we bring so much dirt into buildings and what. And that's kind of what we shoot for. But in the United States, from my experience, unfortunately, and I wouldn't call this the exception, and I wish I could, it's more of a hodgepodge, and we have so many different problems in schools, and definitely a challenge. So with that, we're dealing with older schools in the U.S., some schools that should or are condemned, ready to be condemned, horrific conditions where we have mold and other moisture intrusion and what, and the degree of clutter that we have in schools. I mean, it's phenomenal when you look at that, and you find what we often find in classrooms is just so much clutter and debris. And this is a concern with children, young children, asthma, allergens, exposure as a function of that. And you take into account just one child, while I'm up here right now, you're shedding about 40,000 skin scales per hour. And that's about approximately 1 pound of skin scales per year. And now you take that and add that or multiply by 20 or 30, you got a lot of skin scales and everything floating around. You've got a lot of clutter, you've got a lot of allergens, and these are typical of conditions. And then we add to it, let's put animals in the mix as well. So it's not so wonderful, and we try to work hard with districts to improve conditions. Actually, first met Dr. Messenger in Helena, Montana, related to when he was superintendent there, and very glad to be helping here. Which brings us to Casey Middle School. Now, I showed you conditions of other schools. From my perspective, here, there, and in other countries, Casey is, from all appearances, an outstanding school. I mean, it's got all of the things we talk about: lack of clutter, daylighting, cleanable, lack of moisture, all of these things. There are other attributes as well when we look at Green Star School. It is, for whatever it's worth, it is a LEED Platinum certified building, and I'm not going to say that LEED Platinum guarantees that you have no problems with respect to schools, but that's outstanding as a whole, as a starting point. But it'd be more of, I look at this school as somewhat of a high performance school. And in other countries and in California and across the US, there is this development of trying to get energy efficient and healthier schools for the children. Here's one out of Finland that we've done work in and what. But with that said, even in the best of situations, problems can and do arise. Which brings us where we are now here tonight. If to understand a problem, to investigate a problem, to be able to track it, we have to, we look at it methodically from, we understand the source, we try and identify the sources, we look to the pathway, and then we look to the people. And if you put those together, that also tells you how to investigate and resolve problems. So with that said, what we look to when we're trying to investigate and resolve problems, we're trying to understand the nature of the problem, when it's occurring and where it's occurring. We're trying to understand the nature of the pollutant and the source and look for those sources that we have within the building. We try to understand the pathways, how it moves through the building to the people. We try to understand the pressure relations, which are very important in terms of how that air gets moved from one environment to another, from one classroom indoor to outdoor, one space to another. So, we want certain areas definitely depressurized or pressurized depending on what activity is going on. We look to air cleaning and filtration, and we look to ventilation. And ventilation fundamentally is so important to indoor air. I can tell you that. And that's where often in the US, I just want to use that as an example because we've done so many studies related to ventilation and we understand, I mean, we've known for hundreds and hundreds of years ventilation is critical. But you'd think we'd learn from history as such. Benjamin Franklin said, you know, I'm persuaded no common air from without is so unwholesome as air within a closed room that has been often breathed and not changed. Well, we've looked at it and trying to get information that administrators can use to validate investments in indoor air. And one thing that comes down to is student achievement. So what we found, and this is just an example again, that when you increase ventilation, you also have a correlated increase in math and reading scores, up to 8 to 10%, depending upon the existing ventilation rates and what you might find. And one thing I want to point out here, which I think is important to have as a reference, when we look at these schools and these are not just one or two schools, we're looking at hundreds and hundreds of schools in the US. And what we find, and this is very, very typical, this is I don't want to get too technical here, but this is a distribution of ventilation rates. Now the reason I want to show that to you is see that vertical line there? That is the recommended minimum ventilation rate that is established for schools across the US. Now, in our studies, let me show you what the ventilation rate was. The mean ventilation rate was not even half of that. And 50% of those were below that. I mean, we're not missing the mark. We're dramatically missing the mark with respect to ventilation. Here's another district, 140 classrooms and such. Look at the distribution again. The reason I point this out is because Brad's going to bring this up to give you a reference. And here again was the median for this distribution. I mean, we have to do better with respect to schools. Where are we with respect to Casey? Well, I'll let Brad present some of the data and some of the findings that we have. But you'll find that we're very close to this minimum recommended ventilation standard, which in our studies, we're finding about 90 to 95% of schools across the US are severely underventilated. And that's just atrocious. Now that's also shared in other countries as well. I've seen it in Finland, Denmark, the Netherlands, and that's an important provision that we have to recognize. So with that, I'd like to turn it over to Brad Turk to talk about the Casey data, what we found, and our investigation has been on hydrogen sulfide. What we did and what we'll talk to you about, our part of this is the investigation and looking at the problem. We focused on the source, and the source we were looking for was related to hydrogen sulfide and whatever sources might present that as such. We looked at pathways, how those sources might relate to the people. We looked at ventilation rates being very important. We looked at the pressure relations. If something's being vented outside, is it coming back inside the building? Is the building sucking in air or is it pushing it out? And we looked at people in terms of the nature of the complaint. Dr. Van Dyke will talk more about the people and the health aspect. So with that, I'll turn it to Brad.
Thank you, Dr. Shaughnessy. And thank you for the opportunity to speak. My job this evening is to essentially discuss some of the work that we've done over the past 3.5 weeks, 4 weeks in Casey, and present some of the initial findings and recommendations that we've come up with. This is just a brief overview of my background. I think Richard touched on it. I've been working in this field for over 35 years. I was a research scientist at the Lawrence Berkeley Laboratory in Berkeley, California, and have gone on to start and run my own business for more than 20 years. Worked in schools with Richard and other indoor air people around the country, done presentations and worked with a variety of clients. Again, as Richard mentioned, the focus of this investigation was on hydrogen sulfide. We stepped into the problem early this year. We reviewed some of the information that had already been presented and it was clear that was going to be the primary focus of our work. What are the elements of our investigation? I'll just briefly go through this. I'll try not to get into the weeds too much, but I'll just kind of outline what we did. To start with, we have essentially collaborated with a team of people. Each one of us brings our special expertise to the problem, but not one of us has all the expertise needed to identify and resolve these issues. We started out by reviewing some of the previous studies and investigations that have been done by others, by the district. We talked to maintenance and facilities people, what had been done, what the problems were, what the timeline was, and looked at that documentation. And I'll go on to some of the next steps of the investigation in a minute, but what I want to point out is that throughout this, we apply scientific and fundamental indoor air quality principles to resolving the problem. In some ways, we look at ourselves as really investigators, and so we have to go back to basics to really understand some of these problems. And the bottom line again is we need a healthy dose of common sense when we're trying to resolve some of these issues. We spend a lot of time talking to people, getting feedback from individuals, and as well as reading data off of our instruments. So what, one of the very first things that Dr. Shaughnessy and I did, and I believe Dr. Van Dyke did, is we conduct a walk through the school. Probably the most important instruments that we can carry around are actually attached to our head, our nose, our eyes, our ears. And if we don't employ those to start the investigation, we're missing a big part of it. So we walked around the school, outside, inside. We looked at the ventilation equipment. We looked in the classrooms. We're looking for obvious problems, things that might be amiss that could be resolved without any further investigation. The picture on the left, it just shows us walking around the school. The picture on the right is simply a picture of some of the mechanical ventilation equipment in the school. I might add that the ventilation system, mechanical system in this school is fairly sophisticated and requires a great deal of understanding on operating it and bringing in the required fresh air amounts and distributing it throughout the school. Part of our walkthrough also was to do spot measurements. Now these are not comprehensive exhaustive measurements, but these are for 10 minutes in each space as we walk through. They included air pressure differences, carbon dioxide, hydrogen sulfide. The device on the left is a picture of us making pressure measurements in some of the sewer pipes in the building, and on the right is a hydrogen sulfide monitor, a Jerome 631. Following the walkthrough, we conducted some fairly intensive measurements of building and sewer pipe pressure differences. We suspected that the hydrogen sulfide was originating in the sewer system, either escaping through the pipes themselves, from breaches in the pipes, or possibly through the vents on the roof. And so we wanted to see if we had unusually high pressures in those pipes, and we also wanted to understand the pressures in the buildings. So we conducted fairly extensive measurements of that over a day and a half. So just to jump to the findings, primary findings were three. Our report lists some others. First of all, the scrubbers, filters, and air admittance valves on the rooftop vents for the sewer pipes, they allowed slight pressures to build up in the sewer pipes. And so that we theorized that that slight pressure, if there were any minute leaks or breaches in the pipe, would force the sewer gas into the building. So by taking those scrubbers, filters, and admittance valves off, we relieved that pressure and allowed those gases to vent to the atmosphere. Two, the building was being operated under negative air pressure. In other words, that fairly sophisticated ventilation system in this building had gotten out of adjustment a bit, and it was causing some negative pressures to exist in the building, which could possibly further draw the hydrogen sulfide into the occupied space, along with other things that you don't necessarily want. We also suspect that fresh air ventilation rates may have been slightly low and below some of the ASHRAE standards that Dr. Shaughnessy talked about just a few minutes ago. On the whole, some of the CO2 measurements we did indicated that some of the ventilation rates were okay, other ones were just a little bit low. Our recommendations, we had 9 of them. I'll try to quickly go through these. First of all, we recommended that the carbon scrubbers and admittance valves be removed from the rooftop vents. On the left, you can see I circled in red some of those. This on the right is a close-up of one of them, and they actually just sat right on top of the pipe. And so those were all removed. That task was completed per our recommendations. The next recommendation was to bring together all those various vent pipes, and there was close to 30 of them, through the roof of the school, and gather them together and extend the vent pipes up about 15 feet. And I'm sure you've seen that as you approach the school. The picture on the left and one on the right show a close-up of it. And that was to keep the vented sewer gases away from operable windows and outdoor air intakes in the building. Third, keep the floor drains and other traps filled with water or mineral oil and install drain check valves. That's ongoing. That's a continuous maintenance issue the school will always have to deal with. Every school and every building has to deal with that. That will keep sewer gas from coming out of the floor drains. 4 was to rebalance the ventilation systems in the school and some of the underfloor spaces so they operate at a slight pressurization. That's been completed very recently. It's still being verified. We did some checks today, and an engineering firm is also checking it, and we suspect there may be some additional fine-tuning of the system required. The 5th recommendation was to adjust or modify the energy recovery ventilation wheels. This is kind of an esoteric thing, and the manufacturer is saying they're not sure they want to do that adjustment, and there's still some more work to be done with that. And if there's questions about that, you can write it down. We'll try to talk about that later. The 6th recommendation was to assure that these energy recovery ventilators, which are actually a great part of the school, I might add, they go into defrost mode when it gets very cold, which limits the amount of fresh air that can come into the school, and we suggested those set points be changed, and they're working on evaluating that right now. 7th recommendation was to increase the supply of outdoor air. That has been completed. We did some CO2 measurements this afternoon, and we are starting to already see the effectiveness of that. There's some additional verification needed to be done to assure that that's been completed properly. The 8th recommendation was to consult with third-party toxicologists and health professionals, and that is being done. It was actually being done before we got started and were involved with county and state officials. And finally, our 9th recommendation was to implement a district-wide indoor environmental quality program. Richard and I have done a lot of that work in the past, helping schools set these up. We understand Boulder Valley has a system using their existing work order system to flag complaints and so on. And there's some retro commissioning being planned for schools in the future. So that pretty well concludes what we did, what our recommendations are. We're not done yet. We're going to continue to try to help if questions arise and resolve any remaining problems. Thank you very much. I'll return it to Marilyn.
Thank you, Richard and Brad, for that presentation and data. I'm going to take a moment break so that was a lot of information. If you have questions about all that information, I'm going to give you a moment to write those down before we go on to our next speaker. So Dr. Van Dyke is our next speaker, and we'll address you now.
Good evening, everyone. I really appreciate the opportunity to be here tonight. And just to start out, my name is Mike Van Dyke. I'm with Colorado Department of Public Health and Environment. I've been with CDPHE about 2 years. In the 15 years before that, I really did a lot of research focused on indoor exposures, as research as well as consulting. So I've spent a lot of time looking at this, but the difference of me compared to the other two speakers we've had is that I'm not an engineer. I've really focused on things from a health perspective rather than an engineering perspective. So if you want to know how the ventilation systems are working, these guys know way more than I do. If you want to think about health effects and exposures, I might be able to help you a little bit more with that. So with that, I really want to start and make sure that you all know why I'm here and why I've been asked to be here. So I've been asked to give technical recommendations and a scientific opinion by the Boulder Valley School District Board of Education. I've been doing this working in support of Boulder County Public Health, and I really want to make sure that you guys all know that CDPHE does not have any specific regulatory authority for indoor air quality in schools. So what I'm going to talk about tonight are recommendations. This is not something that we can enforce by law. So I just want to make sure that that's clear. However, I also want to make clear that this kind of work is definitely in line with the mission of my branch. And my branch, the mission of my branch, is to really monitor, assess, and prevent disease, illness, and injury related to environmental, occupational, and toxic exposures. So these are the kinds of things we do. These are the kinds of activities that we get involved in, really to provide technical and scientific support to other county agencies and other agencies across the state. I also want to make sure it's clear that I have not reviewed every piece of data out there. I have reviewed a limited amount of data that's available, and I may really upset a lot of you tonight because I'm not going to offer an opinion of whether this school was safe or unsafe last month, 6 months ago, or a year ago. I'm really going to focus on the recommendations that we're making going forward. So really what I want to talk about tonight is I want to focus on some background information, and I just want to cover this background information to make sure everybody has an idea of how we would evaluate a situation like this. I want to talk about what the indoor air quality goals are being recommended by CDPHE for KCR, and then I want to talk about the recommendations that we've made based on the request of the school board. So first, what is hydrogen sulfide? And we talked a lot about hydrogen sulfide in the last talk, but just to make sure everybody knows, this is a colorless gas with the odor of rotten eggs. This is something that's produced by bacterial breakdown of organic matter. This is not a synthetic chemical. This is a chemical that's common in nature. It's produced by processes in the human body. And in fact, if you measured hydrogen sulfide in your mouth, you could probably get detectable concentrations of hydrogen sulfide in your mouth. And the reason we're talking about it today is because hydrogen sulfide is found in sewer gas. And as Dr. Shaughnessy and Mr. Turk talked about, this is really, we think, the source of the exposure here at Casey. I also want to put out a few numbers, just so people, when they start to see data after tonight, they have some numbers to think about and some numbers to compare it to. So the first thing I want to talk about is odor detection of hydrogen sulfide. So what we know is that it's been all over the board in terms of studies of odor detection of hydrogen sulfide. We looked at 26 studies, and the average odor threshold in these studies ranged from 0.07 parts per billion to 1,400 parts per billion. That's a little bit of a big range. So if you take the average from these 26 studies, the average was about 8 parts per billion. And what an odor threshold is the point where 50% of individuals can detect the odor. That doesn't necessarily mean they could determine what the odor is. It just means that they can detect the odor. And typically the point at which an odor becomes annoying is actually somewhat higher than that. There's some work that's been done that shows sometimes a factor of 2, sometimes a factor of 5, but there's a whole odor science field out there. The next two numbers I want to talk about is we think about hydrogen sulfide exposures in two different ways. The first way we think about it as an average concentration over time. And when we're talking about an average concentration over time, the number that we at CDPHE would compare an average concentration over time to is called the EPA inhalation reference concentration. And I want to read you the definition just because I don't want to get it wrong. The EPA reference concentration is an estimate with an uncertainty spanning perhaps an order of magnitude of a continuous inhalation exposure of a chemical to the human population through inhalation, including sensitive subpopulations, that is likely to be without appreciable risk of deleterious effects during a lifetime. So this number was established by the EPA in 2003. So what I also want to point out on this particular definition is the word continuous. So this is 24-hour-a-day lifetime exposure. It's really important to understand when you're using an EPA reference concentration that it has to be applied in the proper way. So we want to know first that this reference concentration is based on the most sensitive toxic endpoint. That's the way EPA establishes their concentrations. For hydrogen sulfide, this was based on an animal study where they found nasal lesions in rats. And they extrapolated from there with an uncertainty factor of 300 to account for uncertainty for rat to human exposure. This is a very common way that people do chemical exposure concentrations. I mean, they do this for lots of different chemicals. They have a standard process that they follow. The way these concentrations are used are for human health risk assessment. So we try to calculate a risk to a person from continuous exposure to this particular concentration. Now, if we were going to do this for a place like Casey, this is not a home environment where we would say people are exposed 24 hours a day, 365 days a year. The way this would be done according to standard EPA methods is we would take into account a shorter exposure duration. So the number that we would use, we would adjust that number, and I'm simplifying a little bit, but we would adjust that number by approximately a factor of 3, and it would be approximately 5.9 parts per billion. So if we were looking at an 8-hour-a-day exposure, long-term average, that's the number that we would use. The second kind of exposure we look at is a short-term or peak concentration. And for this kind of exposure, the US EPA does not have a number. So the number we usually choose when US EPA doesn't have a number is California EPA. And they are typically very conservative in the way they do things, and they're very thorough in the way they establish these numbers. So Cal EPA has an acute 1-hour reference exposure level of 30 parts per billion. So if we were looking at Casey data, and we were looking at peak concentrations over time, we would take the hour concentrations and we would compare them to 30. So the way Cal EPA defines this is the concentration level at or below which no adverse health effects are anticipated for a 1-hour exposure duration. RELs are designed to protect the most sensitive individuals in the population by including margins of safety. And just to make sure you know, for both of these concentrations, exceeding these concentrations does not automatically indicate a health impact. And on the other side of that, just because you're below these concentrations doesn't always exclude a health effect. So, talking about this 1-hour concentration, again, based on the most sensitive toxic endpoint, for this one, it was based on human studies, controlled human studies. Because it was controlled human studies, there was no uncertainty factor applied. And again, when you apply this number, you only apply this number to 1-hour exposure concentrations. So, just to put these numbers in front of you, odor threshold, let's say approximately 50% of people can smell hydrogen sulfide at about 8 parts per billion. If we're thinking about an average concentration, we would look at an 8-hour average concentration during the occupied time of the school, and we would compare it to a number of approximately 6 parts per billion. And if we were looking at peak concentrations, we'd compare them to this 1-hour 30 parts per billion. Okay? So a lot of numbers. The next thing I want to talk about is measuring hydrogen sulfide. I really want to get across that parts per billion is not very much. I mean, just a comparison, a part per million is like 1 drop of water in an Olympic-sized swimming pool. So really difficult to measure that low. So the standard technology that's used to measure this in a real-time way, in the way that we would think about measuring it at a place like Casey, that would give us minute-by-minute averages, is called a direct reading meter. Okay? Now, the meter that we have experience with, the meter that we know how it works, the meter that we have confidence in, has a range of about 0 to 50 parts per billion. It has a detection limit of about 3 parts per billion. When you get below 3 parts per billion, it gets a little bit squirrely. So we can measure down to 3 parts per billion. But I really want to stress this is the industry standard way of measuring this stuff, and the only way that we can really measure minute-by-minute concentrations in a way that we have confidence in. And then finally, Dr. Shaughnessy and Mr. Turk really touched on this somewhat, but I wanted to put up here, what is the definition of acceptable indoor air quality? So they talked about a group called ASHRAE. ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And they defined acceptable indoor air quality as air in which there are not known contaminants at harmful concentrations, and with which a substantial majority, and they say 80% or more, of the people exposed do not express dissatisfaction. I mean, that's the standard definition for acceptable indoor air quality. ASHRAE also defines the necessary amount of fresh air that should be delivered to an occupied space, such as a classroom, to maintain acceptable indoor air quality. And that's what Dr. Shaughnessy was talking about in terms of, I think he had a number up there, 3.7 liters per second. Is that the right number? Close to it. It changes. That number is a moving target as they update this standard. So here's what the recommendations are from CDPHE. And this is the first time we've put these out here in this way. We have put recommendations forward in order to meet these goals. And these goals are, first of all, we shouldn't have any unusual sources of hydrogen sulfide in a school. And what I mean by unusual sources of hydrogen sulfide are things like sewer leaks, things like sewer gas getting in through the windows, things like drains untrapped. These are unusual sources. Usual sources of hydrogen sulfide are people and possibly food in a school. So you can have natural sources, and those would be considered usual, okay? We also don't want any other harmful chemical contaminants in a school, but that kind of goes without saying. We also want to make sure that sufficient fresh air is delivered to occupied classrooms and other spaces. And we want to make sure that hydrogen sulfide concentrations are maintained at normal indoor levels. So this is the tricky part of all of this, is that I have searched high and low, and there is no such thing as a normal indoor air hydrogen sulfide levels that I can find. If anybody has data on that, I would love for them to share it with me. So really what we want to do is we want to get as close to outdoor air levels as possible. So those numbers we talked about earlier, they're really not that important because we want to get close to outdoor air levels of hydrogen sulfide. And for these goals, we also want to monitor the progress toward these goals with objective measurements and staff surveys on health effects. So in my recommendations, I recommended that Casey do a staff survey. And this is a survey using a questionnaire of all staff that addresses health symptoms that might possibly be related to hydrogen sulfide exposure and in other indoor exposures. This would be something that would be done by CDPHE. All individual survey responses would remain confidential, and we really recommend doing this at 4 points in time. We would like to do it in April, we'd like to do it again in late May, we'd like to do it in October, and we'd like to do it in January. And we would use this data to classify the types of symptoms, to identify potential causative exposures, to determine the timing and location of air quality issues, and to monitor changes over time. As I said, we would do the survey and we would do the analysis. So that would be presented to the district in a written report. And one of the main reasons we want to do this type of survey is because, frankly, people are better sensors than these little instruments are. People are a lot more complex than an instrument that measures hydrogen sulfide. So if we really want to look at the sensor, it is people. So we really feel like this is important. And I really would like to get across to all the staff that are here is that should we do this, it's extremely important that all staff, 95% or more staff, participate in this. We need everyone to give us an answer. Otherwise, we don't want just the people who are having concerns. We want everyone. And that allows us to try and figure out, is there a particular area of the building that's worse than another area? So that is a really important point. The other thing we've recommended is that Casey do hydrogen sulfide air monitoring. And what we've recommended is that we start with outdoor monitoring to determine target concentrations. And once we've determined those, we go on to indoor monitoring, and what we've recommended is 5 different locations in the building at 5 different time periods. And those time periods would really represent different seasons. We know the building changes over time based on the temperature, the ventilation system changes over time, and the way it operates. So we would want to include areas with concerns and those without concerns, in addition to outdoor locations during each sampling period. We've recommended monitoring for 5 consecutive 24-hour periods at each time period, and using one of these direct reading instruments to really maximize the usefulness of this data. And importantly, we would really like to have the opportunity to revise this monitoring plan based on the survey results and based on a review of each set of air monitoring data. We need data to determine a path forward, so we need to review it each time. And we have committed to reviewing this air monitoring data. In addition, the second thing we want to have monitored is the fresh air ventilation rate. And we want to measure the volume of fresh air delivered to the occupied spaces, just like Dr. Shaughnessy and Mr. Turk have done. We want to measure this at the same frequency as hydrogen sulfide, and we want to do this using state-of-the-art methods that can tell us how much outdoor air is being delivered to the space. And in terms of the time periods and those sorts of things, we would also like to reserve the right to revise this monitoring plan should we get more data that suggests something different. So, those are the recommendations, and I think I'll turn it back over to Marilyn.
Thank you, Mike. Again, a lot of information, a lot of scientific data, so I'm going to give you a moment to write questions, and meanwhile we will load Dr. Pacheco's presentation on the computer here.
Okay, well, good evening, everybody. It was a challenge getting here from Denver. I'm Karen Pacheco. I'm going to talk about some of the health effects of hydrogen sulfide. To prepare for this talk, I actually did a lot of reading. So I looked at the various websites that talked about hydrogen sulfide. I looked at the series of questions that were asked, I guess, of the staff about what was their worst fear, what were the things that they were most worried about. And I talked to Dr. Orent about his impressions with the staffs. So I tried to get a picture of what people were actually worried about so I could talk to that effect. I know that there are some people in the audience for whom what I say won't be helpful. But what I've tried to do is to give you the sources that I use so that you can go back and look at them yourself to figure out if this is actually a problem. So I do have nothing to disclose, okay? I'm not hired by the school district. I'm not hired to come here. It's just part of our public outreach that we do. And this is me, all right? So this came from the email, I think, that went out this morning that I said that the building was safe, which actually I didn't. I said that I wasn't really worried about the levels of hydrogen sulfide that were detected. And in this, they say that because the OSHA limits are 10 parts per billion, the EPA puts safe hydrogen sulfide limits for children at just 1.43 parts per billion. And so the first thing I said is, where does that come from? Because Mike showed it on his slides, and actually I did find it also. But certainly, if if any of us really thought that the safe was 1.43 parts per billion, then yeah, it would be concerning to be here. All right, I did something here. Mike. Can you just exit? There you go. All right, so it does come from the EPA website, and it comes under this IRIS, which is Risk Information Systems, Inhalational Risk Information Systems. And that's where they say the daily inhalational exposure to humans likely to be without any risk of effects during a lifetime is this 1.4 parts per billion. And because I was getting confused between parts per billion and parts per million, I made them different colors so I could remember what I was saying. It really is based on this inhalational study, which I actually have with me if anyone is interested. It's in rats. They were exposed to 10, 30, or 80 parts per million, right? Not billion, but million of hydrogen sulfide, 6 hours a day, 7 days a week for 10 weeks. And they looked at what the health effects were, either the no observable adverse effect levels or the lowest ones. And what they really found was that there were no effects at 10 parts per million. They divided that by 300, and they came up with a 1.4 parts per billion. So the 300 is sort of a guess. And that's supposed to protect the most sensitive people from any effects. The nasal tract lesions they looked to see if some of the sensory nerves, the nasal sensory nerves, were being destroyed, and they found that there were some effect at these levels of 30 or 80 parts per million. So the study itself, if you read it, because I did read it this morning, so the lowest observable adverse effect level was 30 parts per million. The no observable adverse effect level was 10 parts per million. So the 1.4 is incredibly conservative. It makes me wonder if it's actually even feasible, right? Because this information, which I think is off the ATSDR, sort of tells what's average, right? If you walk down the street in Boulder, what's average? Well, average seems to be between 0.1 and 0.3 parts per billion. Most urban areas are less than 1 part per billion. But there are sources of hydrogen sulfide, either plants that release it. Geothermal areas will release hydrogen sulfide in the air. And so sometimes you can get levels up to 90 parts per billion near these sort of natural sources. The other interesting piece of information, which also was from the ATSDR website, they have these tox facts, and they list all these different things that I actually thought was interesting, was that we actually produce hydrogen sulfide. We have the breakdown sort of sulfur-containing amino acids by bacteria in the intestinal tract or the mouth. We also have enzymatic pathways that produce it. So bad breath is basically hydrogen sulfide. And they've measured, I can't believe they did this, but they've measured hydrogen sulfide and found from 1 to 100 parts per billion people, I guess, who have especially bad breath. And then they also delicately call this flatus. So in the large intestine, you make hydrogen sulfide by bacteria. It can be up to 10% of intestinal gases. And you can measure levels up to 1 to 4 parts per million with a high of 18 parts per million, which I think anybody who has lived with teenage boys knows is actually an achievable level. Mike, you only have girls. So what function does it serve? It's interesting. It's called a gasotransmitter. So there are 3 that have been identified: hydrogen sulfide. I need a drink of water. Can I? And so the other ones that we do make are nitrous oxide and carbon monoxide. And so I just looked in the literature to see what kind of functions it performs. And this is just a selection. It's necessary. You need to make hydrogen sulfide to sense oxygen levels. The carotid body is actually in your carotid artery. It sort of regulates in part how fast you breathe depending on your oxygen levels. But you use hydrogen sulfide to sense that. There was one study that suggested it protects against the development of Alzheimer's disease. It does protect against vascular scarring when you get a heart attack. And just as Mike mentioned, there's a lot of variability in in how you perceive it. So some people may perceive hydrogen sulfide at 0.5 parts per billion, and some people won't smell it until it's 300 parts per billion. And that, I think, is part of the problem, because some people are clearly more sensitive than others, and it's probably those people that we have to speak to. So these are the enzymatic pathways by which we make hydrogen sulfide. So we use amino acids we get from meat, for example, and break them down to make these transmitters. This was actually from an interesting paper that came out in 2011 showing that hydrogen sulfide, which you can see COH2, you can see hydrogen sulfide, actually improves cardiovascular hemodynamics. So this is a molecule that we actually produce, and it performs certain functions for us as well. That doesn't mean that if you have high levels outside, it's good for you, but it does mean that this is not a totally foreign chemical mediator. So respiratory effects, you know, because it's what's been reported in this school, right? Irritation to eyes, nose, and throat, difficulty breathing for some asthmatics, can cause headaches, can cause poor memory, tiredness, balance problems. It does have an effect, and some people obviously are more sensitive than others. One of the questions that I came across a lot in the survey of what people's long-term concerns were was, are there any long-term health effects? What do we know? Is this going to harm our kids? Are we just going to let them be in this school and then 10 years later we're going to see some impact? Well, I looked. There haven't obviously been very many actual studies, but there are a couple of natural experiments that are interesting. And there are two different studies that were performed in this Rotorua city in New Zealand, which must have been a really fun place to go. But it has these geothermal sources of hydrogen sulfide. And so that's just a picture of the city with the hydrogen sulfide gas emanating from some of the natural sources. So they have monitoring networks, obviously, to warn people who may have too high exposures to evacuate certain areas of the city. And they have monitoring data for 30 years, which I thought was pretty decent. And the levels that they measured were between 0 and 64 parts per billion, right? So kind of low levels, not in the parts per million, but in the levels that you might expect or have been found here on occasion, right? Although those were mostly 8 and 10. So they did these neuropsychological tests, and they did a whole battery of them, sort of memory, attention, fine motor skills, psychomotor speed, and mood. And they divided the exposures into 4 quartiles, and then they looked to see, did people do worse if they had, say, 30 years of exposure to the highest levels? And what they found, interestingly, is that they didn't. And I have the paper if anyone wants to look at it. If anything, they thought maybe the really highest ones, people did a little better, but that obviously, that wasn't statistically significant. But what it told me, at least, is that if you're exposed to these levels for 30 years, it doesn't look like there are long-term neurologic deficits that happen. And then there was one other study that actually just came out. It came out March 30th of this year, looking at the same population, but looking at sort of lung function, incidence of asthma, and incidence of COPD. Sort of the same group of adults, the same age range, sort of current and also H2S exposures for the past 30 years. They did peak exposures. I mean, they looked at exposures in a lot of different ways. And they did spirometry or breathing function on all of them. And then they did questionnaire data. Do you smoke cigarettes? Have you been diagnosed with COPD? Do you have asthma? And they looked to see, are these diagnoses associated with the highest or higher levels of hydrogen sulfide exposure? And they didn't find it. And you know, they listed all the lung function data and didn't find an association. So that to me tells me, all right, it's a nuisance gas, it has effects, but it doesn't seem to cause long-term respiratory effects. So this is just my conclusion slide. It's an irritant. It can cause these short-term respiratory and neurologic symptoms that are very similar to those that were reported in this school. I mean, I don't think that's really under dispute. But the natural experiments in cities with these constant exposures over time didn't show long-term effects on lung function or cognitive function. And so I thought those were some data I could at least share that may or may not be reassuring to some of the parents here. All right, thank you. Great job.
Okay, thank you, Dr. Pacheco. So I want to, again, give you a few minutes to write down questions. Again, there's been a lot of information shared here. Some of the questions we've gotten may have already been answered, but we will be asking them. But please take a moment to write down any questions you might have. Okay, let's start asking some questions. They seem to be in several general categories. Some are about the recent work that has been done, and some is about other gases and issues related to gases, and some are about health issues. So we'll try to answer as many as we can. Obviously, in the half hour we have, we're not going to be able to answer all the questions, but try to group them and answer as many questions as we can. And as I said earlier, we will compile all the questions, talk to the experts, and get information online as quickly as is feasible. So please be patient as we try to answer as many questions as possible. So the first question I have is, when will the balancing be verified, and will reports be made available to the public?
So I'll just answer using the mic so we can get it in the system. So we are in the process. The balancing was finished last Saturday morning. During the day on Saturday, so today is Thursday. I think our window is a week to 10 days that we'll do that. They're just verifying that. So once that's completed, yes, we've been giving updates weekly at the school and more in-depth every 2 weeks. And so we absolutely, there's a technical thing right now. We will give an update. We're using the Casey website as kind of the holding place for our reports. And so we'll either push it to the community, and if it's a little more technical, we'll give note that it's on the website. So you might notice if you've been on the website in the last day or two, we've refreshed that, so it's much easier to find the information listed there, and it's categorized.
Thank you. This next question I'm not sure we could answer yet. How did the changes, I'm assuming that happened in the last couple of weeks, affect the levels of H2S? I don't know that we can answer that at this point.
We have, we'll compare it to the data that we have, and clearly what was presented this evening, those are target areas, and I think Dr. Van Dyke spoke to that we'll look at our outdoor H2S, and I think that comparison, Mike, is what you're considering with that.
So I think we didn't really want to do monitoring in the middle of a bunch of changes. We really want to monitor after the changes have been completed. So we didn't recommend monitoring until after the changes had been completed.
The next question is also about monitoring, and it's about parts per billion monitors set up in the school. Can you address that, Mike?
Is that the whole question?
Yes. Why is it part per billion?
Well, I think the recommendation that CDPHE gave for monitoring did include part per billion, down to 3 part per billion measurements. I mean, there are other monitors out there that have a lower detection limit. I think the main problem with those, I mean, those are Australian-made monitors. We have no experience with those monitors. I don't know anybody that's used those monitors. It's like buying a computer that nobody ever tested, kind of thing. We don't know what those will measure and what they won't. We're starting with a monitor that we've been using to measure outdoor levels, and that's where we're going to start. If the data says we need to go to a monitor that measures lower, we'll talk about that after we get the outdoor levels. So hopefully that answers the question.
Thank you. We have a lot of other questions about other chemicals. if there are other volatile organic chemicals found in 2011 and 2012 testing. Were there other chemicals found in the building?
Based on the data that I saw, I did not see any measurements of those things. And I mean, based on the visual inspection of the building and all the information that we have, I mean, doesn't seem to be another source of exposure to point at and to try and measure other than the sewer gas at this time. I mean, that sort of thing might change over time. It might change based on the results of the staff survey. It might change based on what we see. But at this point, I have not seen any measurements of other chemicals or any reason to do that, based on the data I've seen.
Mike, there have been some measurements conducted by another organization, Quest, I believe, and they did do some total volatile organic compound, but it really doesn't get you down to the individual compound. Now, should you go that direction? You know, I wouldn't recommend it arbitrarily, and it's exactly what Dr. Van Dyke was just saying, is that we could measure for thousands, I mean literally thousands of different compounds, species, organic, biological, but unless our primary approach, and the EPA approach, the NIOSH approach, the other agency approaches, is to look to the source inventory, understand possible sources that might be linked to the nature of the complaints, and then go about making an informed decision to then determine which things to monitor for. They de-emphasize sampling, the agencies, because of the fact that you just don't start out on a sampling kind of wild goose chase. And I think with the symptom surveys that are going to be conducted, and what should Dr. Van Dyke see other indicators of something we should be looking for, or the district should be looking for, I think it makes sense then to go that direction. So.
We got several questions about ventilation in the building and opening windows and how do we improve ventilation, because Dr. Shaughnessy mentioned how important ventilation is. So would you address that subject in terms of ventilation and opening windows?
Well, frankly, when you have a mechanically operated building, opening windows actually will defeat the system. And by that I mean the ability to control, temper, and to pressurize or depressurize whatever you might be doing, you can no longer do that when you open the windows. I mean, in European countries where they don't have mechanical ventilation standards, often they do have natural, quote unquote, natural ventilation, and in those cases, some of those schools that we've looked at are some of the worst ventilated schools that we've looked toward as a composite. So naturally ventilated or opening windows doesn't guarantee you're going to get more air. In fact, if the school is operating the way it should be, you're going to change the balance, and you're actually going to be pushing air from the school outdoors as opposed to bringing it in.
Yeah, I would add that the way we like to run our buildings with ventilation systems is to run all the air through the mechanical ventilation equipment. We have filters in place, we have fans in place to control the volume, filter out possibly harmful particles. So it's really preferred to run your fresh ventilation air through the mechanical system rather than relying on open windows. Now, I understand the desire to be able to control your window openings. I mean, that's a perfectly natural response. However, sometimes, as Richard said, it actually can make things worse in systems that are designed for those windows to be closed.
We have a number of questions about health issues, so some of them are directed to you, Dr. Pacheco, about long-term exposure to H2S, cumulative effects on children.
Okay, but what was the question?
The question is, does long-term exposure to H2S cause joint pain or thyroid problems? There's a recent study about the cumulative effect of H2S on children causing brain lesions. Is that a study that you are familiar with?
No.
So it's basically long-term effects they're asking about.
Okay. Again, when I looked in the regular literature, I didn't see anything about brain lesions. There seems to be a fair consensus that hydrogen sulfide is not carcinogenic, and there are no studies that showed that that could happen. I'm not sure how hydrogen sulfide, because it's a gas, right? And it's volatile. And so, I mean, you can inhale it, but it doesn't just sit there in your body. So it's not clear to me how it could cause thyroid problems. So I guess the short answer is I haven't read any studies that suggested it, but from a methodologic standpoint, I don't know how that would work.
Another question related to health is, are teachers' concerns being taken seriously and treated respectfully, and how's the district getting those complaints and handling those complaints?
So our response to staff for the staff in this building as we've worked through this is that we've asked them to complete a process for referral into the workman's compensation system. And so as teachers have done that, this is an independent group. It isn't an employee of the school district. And so there would be an office visit, and the doctor would process through the symptoms and address those. And if there were need for repeated evaluation or additional evaluation, then the doctor would do that. And so, yes, we're taking it very seriously. And those staff members who have initiated that, they have been clients to go to the doctor, and for the most part, one visit is what's occurred. In a couple of occasions, it's been more than one visit. We receive reports from the doctor to indicate if there are any relationship between the findings that he finds and the conditions that might be in the building, and I would say we're still in process with that, but yes, we are pursuing it, and we're trying to make it as open and welcoming process as we can. And so the fact that we have staff participating in that feel they may have symptoms related to it would indicate that the system is working. So we'll continue to work with workman's comp doctor, and if there's anything, it kind of goes back to Dr. Van Dyke's point, is if there's evidence that there's an impact of anything that could be environmental within this building, then we're going to pursue it. And if that means additional tests or additional interventions around the air quality, then we'll take those. But at this date, we have not gotten any data from that assessment that would take us there.
We have
Seven total.
We also had a question about student survey, if students were going to be included in the survey as well. Mike, do you want to address that?
Sorry, I was reading all these many questions I have. So the question was, will we include students in the symptom surveys? And, you know, my answer is I would not recommend it. And the primary reason I wouldn't recommend it is there's a couple reasons. First, we're really following this over 2 different school years. So we want to follow the same population over time. And I know there is some staff turnover year to year, but not like there is with students from year to year. So we want to follow the same at-risk population over time, over 2 school years. Okay, so that's one reason. The bigger reason is probably because with a staff survey, you're going to get a lot closer to kind of the 95 to 100% response rate that you're going to get with a student survey. With a student survey, I mean, teachers send home stuff to students, and you know it's difficult to get that stuff back from students. So what you would end up with is you would end up with all the responses of people who have concerns and none of the responses of people who don't have any concerns. And in order to analyze the data, we need both. We need the people with concerns and people without concerns to really be able to start to think about where the problems are. So from my perspective, I think this might have just, can you guys still hear me? Oh, yeah, it's still working. From my perspective, I just think a staff survey is much more useful, and you're going to get a lot better data from a staff survey. And then you don't also have to worry about how the questions are worded and try to word them down to, you know, the 6th grade reading level. So these are difficult health-related questions that are hard to ask of kids. You can't collect personal health information in a classroom like that, and you'd also have to have parental consent to collect that information.
One other health-related questions, and then Mike is looking at some of his questions to see if there's a couple that we can answer as our time is getting short here. Could the odor have a psychogenic effect on occupant symptoms? Dr. Pacheco, do you want to address that one?
You mean like people smell a stinky odor and they get symptoms? I mean, from what I've read and from the symptoms that are reported, they sound pretty plausible as being related to either hydrogen sulfide, which appears to be episodic, and I didn't touch on the whole inadequate indoor air issue, but they were really compatible with that. So when in reading these symptoms, I didn't think that people were making them up, in all honesty. They were exactly what's reported for either poor indoor air quality, meaning not enough fresh air intake. People just don't do well in stagnant air, and or with hydrogen sulfide. So I guess I would say no, I don't think it causes psychogenic responses. I think these are real responses.
On that particular, I would agree. I mean, this is one of those issues where it's a really hard issue because people have a physiological response to odor. And trying to determine whether that is a health effect or not a health effect, I mean, that's a matter up for a huge debate by people at a lot higher pay grades than I am. I mean, even the American Thoracic Society has really gone round and round about whether a physiological response to an odor is a health effect or not. So that's a really hard issue. But I have about 7 questions here, and I'm not sure I could classify each one of them, but I'll try. So first of all, have the levels of hydrogen sulfide been tested at the time of the surges? At the time, students and faculty have reported symptoms or strong odors. Basically, has CDPHE been tested at peak concentrations? Frankly, I don't know the answer to that. I mean, anytime you have an odor problem and it's not specific to CDPHE, it's one of those things where you have an event that happens and you can't get people or monitors there fast enough to measure it. I mean, the goal is to eliminate sources of the sewer gas so that these things don't happen anymore. And one of the ways that I think we do that is staff surveys and trying to figure out where these are happening and is there any kind of time period where these are happening. So I can't answer that one very well. So what are the levels of hydrogen sulfide that have been measured at CDPHE? So based on the data that I have seen, and that's been mostly the 2014 data, what I have seen is averages, reported averages, of 0, 1, 2 parts per billion. I've seen kind of 10-minute peak concentrations up to about 21 parts per billion. And if you remember the numbers that we were talking about, I mean, I'd say that averages have been, based on the data I've seen, averages have been 3 parts per billion or less, and peak concentrations have been well under 20. So that's what I've seen. Again, it hasn't been monitored all the time, so other times it could be higher, other times it could be lower. We don't know the answer to that. Do hydrogen sulfides spike when the school is full of kids? And are they the same when the school is empty? Only if Karen's son shows up here. Right. But, you know, the data that I've looked at have been provided in tabular format and page after page of data. So I haven't gone through and calculated the occupied averages versus the unoccupied averages. So based on the data that I've looked at, it looks like that averages during the school day appear to be slightly higher than averages during the unoccupied time. But again, that's just an eyeball of the data. That's not actually analyzing the data. Going forward, we really want to get the data in spreadsheet format to where we could really analyze those sorts of questions to be able to answer that question. Do you want to say more about that?
Yeah, I took a quick look at some of the Quest data from before, and for a few days, there were periodic and fairly regular increases in the H2S levels around noontime. And I don't know what to make of that. The one thought is that when the kitchen is operating, they run their exhaust to increase the depressurization in the building. And so what we've been doing over the past few weeks is try to decrease that depressurization that would exist in the building. And so we're trying to address that.
Our time is running out, and I want to be respectful of your time. We do have an evaluation form we would like you to fill out, and with an opportunity for more questions. And as we promised earlier, we will be answering all the questions on the website, but we do want to be respectful of your time. Okay, Mike has one more question that's burning that he feels he needs to answer. So.
Well, no, I think it's a perfect question to end the night, and I don't think it's just me that should answer it. And the question is, how will you know or verify when the school is good enough? And I think that's an excellent question. And from my perspective, I want to monitor the progress of the school in terms of symptom surveys over time, and I want to monitor the air monitoring data over time. At the end of the day, we'd like to see hydrogen sulfide levels as close to outdoor concentrations as possible. So does anybody else have any success?
Well, actually, I think it is a good question. And then the work that I do, this comes up. How do you know when the building is fixed? And I don't mean to be flip, but I consider a building to be fixed when the reports of problems stop. And I use that as sort of my baseline measurement technique for success in a building. And so the other part of that is that you do need to make measurements, because people in a building may not necessarily know what the ventilation rates are. And so I think it's important to have sort of a hybrid of symptom reporting, and at the same time you're doing measurements, just like what Mike has proposed here. Richard?
Are we doing closing?
Okay, our time is up. We had said this would go from 6 to 7:30, and I think we're about there. Again, I want to, on behalf of the school district, express my appreciation for all of you who took your evening and joined us here. A lot of, want to point out what's on the screen? Okay, a lot of good information going on. So we are going to have copies of the reports and also the PowerPoint presentations will be loaded on the website. And also, if you can't read this, we'll also put this on the website as well, that if you want to communicate additional questions or comments, the communications@bbsd.org, which you get a lot of emails from that email address, you would recognize that, would be a way that you can continue to stay in touch with us so that we can convey that information. So again, I want to thank you for coming here this evening, and if you would fill out the evaluation form, there's another place to put questions or comments. A couple of the questions that I had that I want to address is that we have a really good operationals team, folks who work in operations and mechanical systems. Some of them are here with this evening, and they work alongside these folks. And what we realized is that we needed some additional help with this, because as has been noted by almost each of the presenters, this is a complex issue in a complex building. And so I would like to just, on behalf of the school district, express my appreciation to Dr. Pacheco, Dr. Shaughnessy, Brad Turk, and Dr. Van Dyke, if you would join me, please. This is what these folks do for a living, and they are well recognized and published, and the community service, public service, and doing work alongside us. So we really appreciate their expertise. And what I heard them say is they're going to stay with us, and they're going to stay with us to get this done. You know that we passed a bond issue, thank you very much, last fall. We will be looking at air quality and recommissioning all of our schools, all 56 schools. So when we're going to get Casey where it needs to be with what the work we're doing right now, and we're going to be confident that the concerns will end at that point, and then we're going to make sure that all of our schools have that same high standard as we go forward. So there was a question about student wellness, and I just want you to know what we've done on every concern that has been brought to our attention by a student at Casey Middle School is work back with the students or their families to say if there's medical information or health information that would lead us to find out additional information about the environment, just like we're doing with staff, we are pursuing that. So, and we will continue to do that. We are monitoring the frequency of symptoms in this building compared to peer middle schools in the city and across the school district. And what we have found is that there is no variability. This over time, and we're checking it month by month, from nausea to headaches to the symptoms that Dr. Pacheco described. We're continuing to monitor that. So it's in that normal range. That doesn't say that any one child might not have symptoms that need to be looked at more closely, and we will do that. So again, on behalf of the school district and our Board of Education members, all of which I think made it here by the end, and so thank you for all of you coming out this evening. Take advantage of these contacts. Go to the Casey website. We'll have the PowerPoints and the reports up there soon. So, and Marilyn, thank you for facilitating, again, another assistant helping us work through this. So have a good rest of the evening, hoping the snow's not too deep when you go back outside. Thank you so much.